Section 1.5 is dealing with transformations of functions. So there's going to be a lot of different things that they can do to graphs of functions. We can move them left and right, we can compress them, we can stretch them, we can flip them. There's all kinds of different transformations we can do to graphs. So all of these transformations of the graph, there's things that we can do algebraically to the equations, to the corresponding equations that affect this, and there's patterns that arise with this. So if you look at number 1, we have y is equal to x squared and y is equal to x squared minus 3, and we're supposed to graph both of these and then describe the transformations used to obtain the second graph from the first graph. So if on my calculator I graph y is equal to x squared, and then if I graph in y2 x squared minus 3, so I'm making this my y1 and that's my y2. And your graph doesn't need to be perfect when you're graphing these. As long as it's close, that's all that matters. So my first one looks like a parabola, like that. And my second one, it's basically the same parabola, only it's shifted down. So you'll see that it's been shifted down, and when you're trying to describe how they've changed, it's kind of best to look at two distinct points on the graph. So if I look at the vertex of the parabola and I compare it to the vertex of the new number, or I should say of the new function, it's been shifted down 3 units. So rather than looking at like a random point to tell, if you pick like a distinct point, it can make it easier. So the answer to this would be a vertical shift down 3, or you could say down 3 units. If you just want to say down 3, that's fine. This is technically a vertical shift. Okay, number 2, it's the same thing. So in my y1 and my y2, I want to type in these two equations. So the square root is the second x squared key, and then square root of x plus 5. And let's graph those. So my first one is like that, and my second one, if you look at it, it starts over here at -5, and it goes like that. So if I compare, I would say the most distinct point on this graph would be the point here and here. So if I compare those, I see that it's been shifted to the left 5 units. So it's always how is the second one obtained from the first one? So the first one that they give you, that's kind of our reference point. So this is a horizontal shift left 5, and you could put units if you want to. Again, you could just say left 5. You don't even have to say horizontal shift, but that's the technical way to say it. Okay, then for number 3, we have absolute values. So the absolute value command, I do want to graph it, so I want to press y equals. Then I want to press the math button. So within the y equals menu, I want to press the math button. And if you go over to num, it's the ABS for absolute value. Depending on your calculator, it may actually show up as the absolute value bars. It may just say ABS with a parenthesis. So you may actually see the absolute value bars with like a dotted box. That doesn't really look like a dotted box, but it will show up as a dotted box on your calculator. Or it'll say ABS and give you parentheses, which you can put in your stuff, or in this case an X, and then close the parentheses. So it'll look one of those two ways in your calculator. And then the second one, absolute value of x minus 4, and I want to make sure to be outside the absolute value when I do the minus 7. So if you have the old one, it's going to be x minus 4, and then minus 7. So if I graph this, the absolute value graph looks like a V. And if we look closely at this, 4 and right there, again, your graph doesn't need to be perfect. But if I compare the point here with the point here, this one has been shifted down 7 and right 4. So a vertical shift down 7 and a horizontal shift to the right 4.